Title: AI-assisted generation of difficult math questions. Abstract: the paper introduces a novel approach to generate challenging math questions by leveraging the strengths of large language models, LLMs, and human-in-the-loop methodology. This method aims to address the unmet demand for diverse and difficult mathematics questions, which are essential for training and evaluating ILM's mathematical reasoning capabilities. Introduction: significant advancements in LLMs have led to their ability to understand and generate complex mathematical content. However, finding new, varied, and challenging questions is becoming increasingly difficult due to the limited availability of high-quality, varied, and difficult mathematical questions. Relying solely on human experts is not scalable, while LLM-generated questions often lack the required diversity and difficulty. The authors propose a design framework that combines the strengths of LLMs with a human-in-the-loop approach to generate a diverse array of challenging math questions. Initially, leveraging LLM metacognition skills, a strong LLM is used to extract core skills from existing math datasets. These skills serve as the basis for generating novel and difficult questions by prompting the LLM with random pairs of core skills that must be utilized in the question. The use of two very different skills within each question makes finding such questions an out-of-distribution task for both LLMs and humans. The pipeline employs LLMs to iteratively generate and refine questions and solutions through multi-turn prompting. Human annotators then verify and further refine the questions, with their efficiency enhanced via further LLM interactions. Applying this pipeline on skills extracted from the math dataset resulted in Math2, a dataset of higher quality math questions, as evidenced by lower performance of all models on Math2 than on Math and higher performance on Math when using Math2 questions as in-context examples. The methodology seems applicable to other domains requiring structured reasoning and potentially as a component of scalable oversight. A striking relationship observed between models' performance on the new dataset suggests that successfully solving the question in Math2 requires a non-trivial combination of two distinct math skills. The paper also presents a 5-step pipeline for generating high-quality, challenging mathematics questions, involving skill pair validation, question generation, attempted solution, question validation, and final solution. The authors emphasize the importance of using random pairs of skills, which necessitates out-of-distribution thinking and results in questions that are harder than those in existing datasets. They also discuss the connection to scalable oversight, highlighting how human-AI collaboration can lead to more novel evaluations. Comparing the zero-shot chain of thought, COT, performance of various models on two different datasets, Math and the newly generated dataset MATH2, models demonstrate a lower performance on Math2 compared to Math, with proprietary models exhibiting the smallest decrease in performance. Furthermore, the authors discuss the interesting relationship between Math and Math2 scores, showing that Math2 questions are more useful than Math questions when used as in-context exemplars for various LLMs. They also shed light on interesting behaviors and failure modes of leading LLMs observed during the question generation process. Overall, the paper presents a structured approach to generating challenging mathematics questions that combines the strengths of LLMs and human expertise, providing a robust and comprehensive evaluation of mathematical skills. The proposed approach for generating difficult math questions employs a 5-step pipeline, leveraging advanced models to create high-quality questions. The process begins with skill pair validation, where a large language model assesses the qualitative similarity of two skills, excluding similar skills to prevent simpler questions. The model then generates a question and brief solution requiring the application of both skills, with conditions ensuring high-quality questions. The generated question and solution are validated against a fixed rubric consisting of 7 criteria, including single answer requirement, exact answer requirement, and computational tractability. The pipeline generates and verifies 180 difficult questions to create the Math2 dataset, which is demonstrated to be necessarily harder than the Math dataset. Human verification statistics show that 43.89% of the questions or solutions were modified by annotators to increase difficulty or correct errors. The experimental setup involves extracting skills from the Math dataset and generating questions using the proposed approach. The generated questions are evaluated on a variety of language models, including MetaMath, Mammoth, Gemma, and Llama 3 series, as well as larger proprietary models. The results show that the generated questions are better in-context exemplars compared to standardly used exemplars. The comparison of zero-shot COT performance on the generated dataset versus the math test set reveals a surprising pattern. All tested models have significantly lower performance on Math 2 than on Math, but a linear relationship between the two scores suggests that the relative drop in performance is well predictable. The authors propose that this relationship may be due to the fact that Math 2 questions genuinely require applying two very distinct skills. The Math 2 dataset is shown to be effective in evaluating the performance of large language models in solving complex mathematical problems. This research presents a novel framework for human-AI collaboration in generating challenging mathematics problems. The approach leverages large language models, LLMs, to identify key skills necessary for solving math problems, which are then refined by human raters into creative, high-quality challenges. The framework involves several stages, including identifying key skills, generating initial sets of questions, and refining these questions through human oversight. The authors evaluate the performance of various LLMs using the refined set of questions, demonstrating that few-shot prompting with exemplars retrieved from a generated set of questions, Math 2, outperforms vanilla few-shot prompting. The results show gains of up to 3.75% for Mixtral 8x7b Instruct. The authors also provide examples of creative questions generated by the models and refined by human raters, illustrating the potential for this approach to produce high-quality, challenging math problems. The proposed pipeline leverages named skills from the math dataset and multiturn interactions with advanced LLMs to generate questions combining pairs of skills. These questions were reviewed and refined by human raters, resulting in a new math evaluation Math 2 that assesses the same skills as the math dataset but is significantly more challenging for leading models. The pipeline produced questions with greater novelty and difficulty compared to those in the original math dataset. The authors discuss limitations and future work, including optimizing prompting strategies, reducing human verification through automated validation tools, and enhancing the pipeline with a training-based feedback loop. They also plan to release detailed information about their pipeline to encourage further research and development in the field of open-source math models. The potential application of the proposed framework to efficiently produce high-quality data in domains beyond mathematics is also discussed. The development of the Gemma AI model and the introduction of the Open Math Instruct 1 dataset, comprising 1.8 million math instruction tuning data points, aim to improve the performance of AI models in solving mathematical problems. A novel approach to solving geometry problems without human demonstrations is presented through the Solving Olympiad geometry model, which achieves high accuracy and outperforms human solvers in some cases. The use of chain-of-thought prompting is discussed as a technique to elicit reasoning in large language models, significantly improving their ability to generate accurate and logical responses. The skill mix evaluation framework is introduced to assess a model's ability to combine multiple skills in solving complex problems. The MetaMath model is presented as a tool for generating mathematical questions based on given skills, enabling the creation of customized math exams. The challenges in generating high-quality questions for evaluating the reasoning abilities of large language models are highlighted, including the need to filter out questions requiring brute force calculations or nonsensical questions. The authors propose adding explicit conditions to check for computational tractability and solvability in the verification prompt and suggest verifying the uniqueness of answers produced in multiple self-consistency trials to detect nonsensical questions. The paper discusses strategies for mitigating failure modes in the question generation pipeline, including the use of multiturn human-AI interactions and explicit clauses in the question validation prompt. Examples of problematic questions and solutions are provided, and the challenge of finding a needle in the haystack is addressed by replacing referential terms with actual skill names in the validation prompt. A well-structured question meeting the criteria for evaluating the reasoning abilities of LLMs is presented, demonstrating the effectiveness of the proposed approach. The paper discusses the development of a system that uses large language models, LLMs, to generate math problems and their solutions, mimicking the thought process of a math teacher. The authors highlight several failure modes, such as generating questions that are too difficult or too easy, or that require brute force computation rather than reasoning. To address these issues, they introduce a validation step where the generated questions are evaluated for their suitability, including checking syntax and grammar, ensuring well-structured and easy-to-follow questions, and verifying sound mathematical reasoning. Human verification is still necessary to eliminate all potential failure modes. The authors observe instances where the models exhibit creative behaviors, such as considering computational tractability even when not explicitly asked to do so, attributed to the role-playing nature of the prompts. They also discuss considerations for human annotators, who are tasked with double-checking the validity of the generated questions and solutions, looking out for failure modes, and improving readability, quality, and difficulty. A comparative analysis of model performances on generated data versus their performances on math shows a quadratic relation between the two. Smaller models generally show larger degradation in performance compared to larger models, with the exception of the Gemma family of models. The analysis of performance degradation on smaller models reveals that they generally experience larger relative performance declines compared to larger models in the same family, aligning with conclusions drawn in Aurora and Goyle, 2023, and Yu et al. 2023a, highlighting the importance of compositional generalization in larger models. The skill extraction process yields 97 skills out of 114 extracted skills, with each question representing 2 skills. The generated set of 180 questions is human verified, ensuring the accuracy of the extracted skills. The experimental setup utilizes 280 GB A100 GPUs and 72 GB of RAM for open-source LLMs, while 25 parallel workers are used for evaluating GPT-4 Omni and GPT-4 Turbo, and 2 workers for Claude 3 Opus. The skill composition using different models is demonstrated by prompting GPT-4 Omni, Claude 3 Opus, Gemini 1.5 Pro, and Llama 370B Instruct and Llama 38B Instruct to generate a question combining area calculation skills and algebraic manipulation skills. The responses of each model are provided, showcasing their ability to compose skills and generate math questions. The solution to the generated question involves finding the area of a rectangle and a triangle, using the coordinates of the vertices, and requires algebraic manipulation to find the value of k. The correct solution yields 2 possible values for k, 2/3 and 4/3. The research paper presents a comprehensive approach to generating math questions that test both algebraic manipulation skills and area calculation skills. 3 mathematical problems are introduced, each requiring the calculation of areas of geometric shapes, algebraic manipulation of expressions, and solving quadratic equations with radicals. The problems are designed to be challenging, involving nested radicals and precise algebraic manipulation, yet provide a clear and logical flow of ideas. The solutions to these problems demonstrate a range of mathematical concepts and techniques, including the use of geometric visualizations and algebraic manipulations. The authors then discuss the development of a system for generating math questions that test multiple skills, providing examples of questions and their solutions, as well as prompts for validating skill pairs and generating new questions. A specific example is presented, requiring students to calculate the area of a region bounded by a curve and the z-axis, which involves integrating the function with respect to x. The authors also detail the prompts used in various stages of question generation and evaluation, including skill pair validation and question generation. Conversations between an AI agent and a teacher are presented, focusing on framing mathematical reasoning questions and evaluating students. Example question-answer pairs are provided, ensuring the complexity and difficulty of the skills in the generated question are similar to those in the example questions. The system aims to generate challenging math questions that test multiple skills, including algebraic manipulation and area calculation, with a focus on precise algebraic manipulation and geometric visualizations. The proposed AI model, trained on a large dataset of text from various sources, leverages natural language processing techniques and machine learning algorithms to generate coherent and contextually relevant text. The model's architecture consists of an encoder and a decoder, where the encoder processes input text to generate a representation of its meaning, and the decoder uses this representation to generate new text. The model is trained using a combination of supervised and unsupervised learning methods, enabling it to learn both the structure of language and the nuances of human communication. Experiments demonstrate the model's capabilities, including generating text similar in style and content to the input text, generating text based on a given prompt or topic, and engaging in conversation-like exchanges with humans. The model's performance showcases a significant advancement in natural language processing and AI, with potential to revolutionize human-machine interaction. A comprehensive analysis of two mathematical skills, Skill 1 and Skill 2, is presented, along with sample questions and solutions. A new question requiring the application of both skills is introduced, with a detailed prompt emphasizing the use of in-context exemplars. The evaluation section outlines a prompt for assessing the model's solution, tasking a professional math teacher with comparing the student's solution to the correct solution and determining correctness. The evaluation process involves a step-by-step explanation of the thought process, followed by a yes or no answer indicating the correctness of the student's solution. The authors encourage the use of prior knowledge and understanding of the skills beyond the sample questions provided.